Okay, let's go over this. The quantity AD minus BC is called the what of matrix A? Determinant. Okay, if CA equals I and AC equals I, C is called a inverse. And true or false, the inverse of A inverse is A? True. Okay, so today we're going to learn what an inverse matrix is, how to find one, and how to use it to help us solve the equation AX equals B. Now, we already have a method for solving the equation AX equals B, right? You can set up the augmented matrix and row reduce it. But today we're going to learn a new method that involves using an inverse matrix. Okay, so I've got a matrix A, 1, 4, 1, 6, and I'm going to find its inverse in two different ways. Okay, so the first one says that if A is the matrix A, B, C, D, then A inverse we find by doing 1 over the determinant, AD minus BC, times a matrix slightly adjusted, right? How do I change it? Swap A and D. Yeah, B and C stay in their locations, but you change the sign. Yeah. Okay, so my matrix A is 1, 4, 1, 6. So my A is 1, my B is 4, my C is 1, and my D is 6. Right, so when I find A inverse, okay, in this case, it's going to be 1 over A times D is 6 minus B times C is 4. I'll just do it all in one step. 1/2. 1/2 times my matrix. So my 1 and my 6 switch. So it becomes 6 and 1. And my 4 and my 1 stay in their location, but they change sign. And then to multiply a matrix by a scalar, you just multiply every entry by that scalar. So I'm going to get 1/2 times 6, which is 3. 1/2 times -4 is -2. -1/2, 1/2. So there's my A inverse. So this is a formula for finding the inverse. It only works for a 2 by 2. Okay, so that only works for a 2 by 2. I'm going to show you another method, and the other method can work for any square matrix. Okay. Yes, only a square matrix can have an inverse, but not every square matrix has an inverse. Yeah. Okay, so method 2, you set up an augmented matrix, and we put the given matrix 1, 4, 1, 6. Augment with the 2 by 2 identity matrix, which is 1s in the diagonal, 0s everywhere else. Okay. And then you row reduce it. And I'm just going to have my calculator do it. Okay, so I need to edit matrix A. And this is now 2 rows, 4 columns. And I've got 1, 4, 1, 0, and 1, 6, 0, 1. Go back into the matrix menu, do math, RREF of matrix A, and we get, it row reduces to the identity shows up on the left. Okay, so my identity matrix is now on the left, 1, 0, 0, 1, augmented with 3, -2, -1/2, 1/2, which is what we got using the formula. Okay. So this method works for larger than 2 by 2. If you have a 2 by 2, you can really quickly put in the formula, get the inverse. If you have 3 by 3 or larger, you can do this method. Augment with the inverse and row reduce. Okay, so now the purpose of the inverse is that it can help me solve the matrix equation AX equals B. All right, so if I have the matrix equation AX equals B. Okay, so just like when you're solving a basic linear equation, like from a really basic algebra class, whatever you do to one side of the equation, you can do to the other, right? And the idea is you want to multiply by something that will undo what is being done to x, right? I would like to get the x by itself. So if you multiply both sides of this equation on the left by A inverse AX equals A inverse B. So I multiplied both sides of the equation by A inverse. The only thing you have to be careful about is that you have to, if you multiply the left side on the left, you have to multiply by on the right side on the left, because matrix multiplication is not commutative. So see how I put the A inverse on the left on both of them when I multiplied. All right, so A inverse times A is the identity. So I get the identity times X equals A inverse B. But what is the identity times X? X. The identity is the matrix that functions like 1 does in the real number line. When you multiply by it, it just gives you that thing back, right? So X, we can calculate by just doing A inverse times B. So I have A inverse. They asked me to solve the matrix AX equals B, where B is the vector 1, 2. So X is just going to be my A inverse, 3, -2, -1/2, 1/2 times B. And I can do the matrix multiplication in my head, or I could type it into my calculator. I think I'll do it in my head just for practice. So this is a 2 by 2. This is a 2 by 1. So my resulting matrix is going to have what dimensions? 2 by 1. So I like to kind of just put in my dimensions of the result. And then we get to multiply first row times the first column. First row, first column, the result will go in row 1, column 1. So I do 3 times 1 plus -2 times 2, and I get -1. Then I do second row, first column. That's going to go in row 2, column 1. -1/2 times 1 is -1/2, plus 1/2 times 2 is 1. So 1/2 is the solution to that equation without having to do row reducing algorithm. Any questions on that? Okay. So I've got A, B, and C are all invertible n by n matrices. So they're square. The dimensions are n by n. So I want to solve this equation for x. A times B plus CX equals C. So it's the exact same general properties that you can do when you're solving any equation. Do the same thing to both sides, trying to get the x by itself. You just have to be careful with the matrix multiplication not being commutative. So what would you do first? If those were all just real numbers, what would you do first? Distribute the A. Yeah, so I would get AB plus ACX equals C. How do you divide matrices? Oh, right. Yeah, okay. Yeah, if they were just numbers, I might divide by A. You can't. No, we don't have a. There is no. It's not defined. Yeah. Yeah. So, but what we could do is you could multiply both sides by A inverse if you wanted to move that over, right? So maybe we can do that if we want to start there. We would say A inverse A times B plus CX equals A inverse C. So I left multiplied both sides by A inverse, right? So A inverse times A is just the identity, and the identity times anything is just that thing. So those like cancel. So we have B plus CX equals A inverse C. Now what? If I want to get the X by itself, subtract B. And so I have CX equals A inverse C minus B. And I know that can be done because everything is n by n, right? So A inverse C would also be n by n, B is n by n, so I can subtract them. And then how do I finally get the X by itself? Multiply both sides by C inverse. Okay, so I'm going to have C inverse CX equals C inverse times the whole right side, which is A inverse C minus B. So C inverse C times X is X. And then I can distribute my C inverse if I want, or you can just leave it like that. They're the same, right? So I could have C inverse A inverse C minus C inverse B. No, only if they're right next to each other. Yeah. Yeah, because of matrix multiplication not being commutative. Yeah. C inverse A inverse is not necessarily C inverse, so. Right. Only works if the C inverse and the C are right next to each other, because matrix multiplication isn't commutative. Like in your brain, you're thinking like if C, it could be like a half and 2, right? Like you're thinking of them as reciprocals, and it doesn't matter where they show up in a multiplication string, they would cancel. But because you can't change the order, you can't cancel those. I know. All right, is X a matrix or a vector, and what size is it? It's a matrix. What size is it? Yeah, n by n, because it's made up of products of and differences of n by n matrices. So it's an n by n matrix. Okay, you try some.